well, it's weird because I prepared it in French now and I will switch to English. Well, we'll see how to develop a open source RAG using OpenSearch. We wanted to sponsor OpenSearch because they were OpenSearch developer, but we saw that the OpenSearch developer are not sponsoring OpenSearch much than us we did. So first thing first, who are we? We are Adelean. We are dev. We are expert in technology of search engines, and we are integrator of Elasticsearch, OpenSearch, and Solar. We offer also consultancy and formation. We do a lot of conferences as well. We have this beautiful meetup. And we are developer of our own solution, HU, that is our e-commerce search engine. And also our lovely Podot site, which is a special search engine. This on that we can use to. It's like more like a GitHub, let's say. We can collaborate together to have a better search engine. So yeah, LLM. It's since 2019 the first LLM was out from one, let's say, transformer well out. We had many companies that are investing their money, their time in this technology. And I think it's not just a buzzword, it's something real, it's something that we are really using every day, I would say. And it's not just big actors of the domain of computer science in general, but it's also sometimes also, let's say, small actors. We have also open source, thanks to God, we have also open source LLM. And we will focus on that today. Yeah, this is a line of time that's showing a bit how the different company are investing. And we should update it because so the sondage question: how many of you do use ChatGPT or any other LLM for all the tasks that are like language treatment related? So when we want to reformulate a text, when we want to translate a text, so we give a big test and we want a big testing output. Personally, I do it a lot with correction, traduction. And how many of you give comments to generate text? So small input, big output, or generate code, of course. And how many of you? This is okay. How many of you do use the large language model in general to surf the web or to search information more than surf the web? Search information, like we use ChatGPT to search information. Yes, we're gonna focus in this case in the last use case, so in searching information, because searching information using LLM has limitation, big limitation. So one limitation that we have no real-time knowledge. If we ask what happened the 8th September 2022, does anyone know what happened the 8th September 2022? No. It's the day the Queen Elizabeth passed away. But if we ask that on a normal search engine, on Google, on Bing, we're gonna have the answer. If we ask that on a large language model, which was trained on data that are not too recent, well, it's not gonna answer to us. It's gonna give us a good answer. So it's gonna say, I don't know. In best case, we have also some limitation, like we saw some sort of horizontal limitation, I call it, like in time. We have also some vertical limitation. So if we have something in a specific domain, maybe you won't be able to answer us. And we have also what we call a hallucination. This is super funny because sometimes the model is going to create fake information. Like in this case, I asked who was King Renoir from the Chanson de Roland real? And he said, oh no, it's not real because it's a character of the Chanson de Roland. He is a Muslim king, and he is in the poem. But in reality, my question was like a tricky question, because no, King Renoir is not a character of the Chanson de Roland. It's just my invention. So I just created the question to to create this sort of fake answer with wrong information, wrong creation. He created all of his own this weird information, weird answer. And finally, we don't have any source. If we ask him, for example, to quote us, to give us any source about 5 superconductors, we are not going to have any source. We can never verify if the information is real or not because of hallucination if we don't have any source. So yeah, we can use ChatGPT to search certain things, but we are not always sure that it's going to work. So why we have these problems? I'm sorry, I can't stop this slide, but it's going to be annoying because the cat are all playing. But why? Because LLM are trained on big data, and their training is limited to the data we ingest them. And secondly, because they try always to find the compensation, a treat, like the cat. So they are trained to generate text. So they're always their main goal. We can fine tune them. We can do whatever we want. But at the end, deeply, their main goal is gonna be to generate text. That's their nature. And so we come to the solution. So the solution is RAG, Retrieval Augmented Generation, which we translated in Generation Augmentée par Expression. There are many ways to translate this. I hope this is the best way to translate it in French. How does it work? So we send a query to our interface. Let's say we have an interface. We send our query, like if we were chatting with ChatGPT, for example. The query doesn't go directly to the LLM. It's used to search information in our database. It can be a vector database, like in this case. And then the search engine works as a retriever. That is not a dog. It works like a retriever. It takes the document. It doesn't give it back to the user. This is the most relevant document, of course. But it uses them into a prompt. It uses the document to create what we call a prompt. The prompt, in this case, is made up by 3 parts. We have the instruction that we send to the LLM. We have the context, so our document, and we have the question that the user made. And then we send all this to our large language model, and then we have our response. I have a question. How many of you did note the user query? And how many of you knows about the question? Okay, you're not a fan of The Office. No. Sadly, it's a quote really famous from The Office. Yeah. So we say that the search engine changed a bit its role. Now it's a retriever. It doesn't communicate directly with the user, but relevance is still super important, because when we create our prompt, we are using the document that the retriever, so the search engine, found the most relevant document. And so if the document are not relevant with our query, it's going to. So one of the biggest challenge for finding the right document is that the query gonna be really verbose. There's gonna be a lot of words, and so we need, if we are using keyword search like BM25, we need a good analyzer, good filters. We may need name identity recognition. So we need to prepare our search engine to find the right document. So it's challenging. Otherwise, we can try to use vector search, semantic search, and we can use also. We have also the possibility, a third possibility, to use both of them. So hybrid search. So here we have an example of RAG. This is actually Copilot that I use quite a lot. I don't use it to surf the web. I still use Google, but I use Copilot quite a lot. How many of you do use Copilot for like everything, like to create images, to it's super, it's insane. I was getting really well. So we have a new way to interact with the search engine. We have answer that finally they have their own sources, so we can verify if they are fake or not. And we have a solid system prompt that we are not gonna see, but it's something huge because no, I'm gonna show you. It's something huge. It's all the instructions that are sent to Copilot to work as it works. So it's like it says, what's your name? How you should identify yourself? You should introduce yourself. It use how to use certain function, like for example, if it has to create an image. It's extremely complex prompt, and yeah, it works. I would say fairly well, probably really well. So the question is, why do we need an open source RAG if we have something that works super well? Because our data are in danger. Because sometimes our data may be used to train the large language model. In the condition of BARD from Google and of Copilot, we can find that our information or data can be used to improve our product. Don't enter confidential information. So, I mean, sometimes we enter confidential information, maybe not, maybe yes. Who knows who's confidential, who doesn't know? But it's still a danger. So, I mean, I prefer my data to be safe rather than that my data are used for training. And also to reduce cost. When we use OpenAI API, for example, we are spending some money. When we use, for example, GPT-4, we are spending some money from the input we send, from the input we send that is calculated in thousands of tokens, and for the output, we can control both, but input and output it's like 10 cents per thousand of tokens. And this is a graphic that show a bit the impact of using its own the OpenAI API, or a model deployed on a VS with Hugging Face, or a model deployed on a serverless GPU. Data from inferless.com that offers serverless GPU. That's why they wanted to prove that. So what do we need to have our own RAG? We need our favorite search engine, OpenSearch. We need a large language model. We picked Zephyr with the 7 billion of parameters. It's a fine-tuned version of Mistral that was made by the guys of Hugging Face. And we need a library that can connect the two things. And that's why we picked LangChain, and in particular Llama CPP. So we are at the demo time. For this demo, well, I'm gonna show you a bit of OpenSearch, and then I'm gonna show you a bit of code, and then we're gonna see how it works all together. And the use case is e-commerce. So we are in the domain of e-commerce, and we are in the domain of something I really like. I probably buy too much, but it's sport outfit, particular shoes, running shoes, because I need. Yeah. I hope it's not going to be messy to do this. Yeah. Can I reduce the? Oh, I can't reduce. Well, it's not important. So, do we have enough time? Maybe. First thing we have to do when we are working with OpenSearch is that we have to upload and deploy our model. So I'm gonna do some small demo here. Even if we're not supposed to do it. When we upload our model, we create a task that is the task that is gonna upload our model, and then we have to get the model ID that is downloading, and that if it's not downloading, it's because the Wi-Fi is not super good. So we're gonna have the model ID here when this finish. Let's say this is the model ID, because it's not gonna take too much time otherwise. Okay, no. Well. Then we have to upload our model, and then we can use our model to create a vector. So we use the phrase Adelean uses OpenSearch, and this is going to create a vector for us. We can use this vector, and this is really a cool feature, into our pipeline that's already made, I think. And we can use our pipeline into the definition of our index. So in this case, I have an index that's called running shoes, because we are in this kind of use case. And it's really important to set the index KNN at true and use the pipeline that we just created, and have a field that we're gonna is gonna be a type KNN vector. And when we are sending our documents to OpenSearch, to this index, is gonna use the pipeline to generate automatically out our vector. Why? Because in our pipeline we define a field map. We define our input field and our output field. This is super easy to do, super cool that it's so easy. And when we send our document, was updated, we're gonna find our vector normally here. Okay, so we have our description vector that is a lot of numbers, so we're gonna close it, and our description. So the vector was automatically generated. So we can use the neural search. It's always called in OpenSearch, I think. Neural search. Well, it's called neural search. So why not? To find the fastest shoes, which I confirm they are the Saucony and the Mele. So how does it work in Python? What did you use in Python? It's extremely simple. Yeah. So we used our neural search query to retrieve all our documents. First thing, connected to our cluster, in case OpenSearch. We use Llama CPP with our model, the Set 7. Why, I don't know why I was switching to French. And we are essentially creating our prompt. It's extremely the easiest prompt ever. So we are taking our documents. If you're familiar with Elasticsearch or with OpenSearch, you know that all the search results are inside its object. And we are putting our document into our context. So we are creating our context. So what we're doing, as I said before, we are giving the instruction, we are giving the context, and we are giving the user query. And we're creating using the function LLM to create our response. But then we are streaming, not here, we are streaming character by character, and we are showing at the screen. So to give you an okay. Okay, so to give you an example of how this works, let's choose to go fast. So this is gonna automatically trigger the vector search here. Oh, no. And it's gonna find the answer. I'm gonna try to put it. Well, it's gonna it's not printing the entire answer back because I'm in a big screen. It's gonna recover the result of our search. It's gonna send them to the LLM model, and then the LLM model is gonna give us an answer that is proper to the documents or to the context that we sent them. Quite cool feature that we can see the number of tokens that were generated, and extremely it's really incredible the fact that this is running just on the CPU. It's super fast and it's not using much RAM. It's using less than 4 GB of RAM, so it can run essentially even on a phone. And yeah, that's just insane, because a few months ago, like a year ago, yeah, we couldn't do much of this. It was not working super well, but now, yeah, we can do all of this for free. So I don't know where it's okay. So to conclude, on est là. Okay, yes. To conclude, yeah, the conclusion. So we saw how the RAG can solve the major problem of the large language model if used as a search engine. As I said, the improvement that have been done in developing open source large language model in the last months has been insane. And once again, OpenSearch is our best solution to do this, to do the role of the retriever, and to do these things. Merci. Thank you. If you have any question, we can I can answer while we are eating.
How did you end up deciding which open source language model to use?
Yes. So essentially, I tried a few open source open source model. What I didn't say that you have to give a certain prompt. You have a certain format, and in some case the format is kind of too restrictive with this model. You can not follow the constraint of the prompt, and you can just let's say talk to him freely, like if you were talking to a friend. It was just that, and then it's light, it's quantized. This one that I use, it's 4 giga, like memory. That's why I picked this one. And for a demo, then if we have more resources, we can take something bigger that is going to perform way better than this. But as I said, I mean, a few months ago, this was not possible, at least with this speed, with this rapidity. That's why I picked this one. You're welcome. Yes.
Is there an official open source Python client?
Official OpenSearch Python client.
Yeah, we have a high level REST client and a low level, or yeah, high level client and a low level REST client.
Yeah, because I didn't use it.
Actually, there are 3. There's also, oh, sorry. Yeah, there are 3. There's a high level REST client, a low level client, and then there's also an ML client, which I don't know why we don't just have one, but you know.
So you showed us basically an interface or 2 base LLMs. One is Mistral and one is Llama CPP, like 2 different demos perhaps. But is that right? First,
no, the model that I showed was the LLM that I used was Zephyr, which is a fine-tuned version of Mistral. So we can say it like you can say it's almost like Mistral. Mistral has some semantic to use that is quite, I mean, for me, complicated. When you send a prompt, you have to use some sort of some semantic, and with this model, I didn't have to do that. So yeah, I just used one model to do this, which is Zephyr. Llama CPP, it's what we call a Python binding, so it's a component that was originally made for C++, and it was exported into Python, and essentially it allows you to use essentially Hugging Face model locally. That's what it does. It's just a library.
Okay.
So the powerful thing also is that we can use whatever model we want from Hugging Face at least. And then we have other library. I didn't see all everyone is working on this sector, so there are so many different new things that you can use. It's really just a new word.
Thanks.
Oh.
other questions? I have a question. So how can you answer now to the question of what's happened on the 22nd of September?
Comment
22?
comment on peut répondre? Mais so we would need like big data essentially. So we retrieve the most relevant document from the internet, and we give it to the LLM. I'm sure it can answer to that.
Yes, I mean, you have to kind of index some.
Yeah, we have to
data
index
somewhere.
the news, or yeah. I took the easiest use case, the one of the e-commerce. But yeah, we could have done that as well.
Thank you. So it's a follow-up to your question. How do you decide what's the most relevant information or news on September 8th, 2022? There was like a Queen Elizabeth.
You rely on the retriever.
Okay.
So you can decide to use, as I say, the keyword search, like BM25 search, or the keyword search. As I said, the only problem that you need to have to prepare your own search engine. So you have to use your good tokenizer, your good filters. You have to prepare everything. Or otherwise, you can use directly vector search and retrieve the n top documents that are the documents that are the most relevant. So it's the retriever, the search engine, in this case OpenSearch, that's gonna retrieve the most relevant documents. It's not me to choose, it's the retriever that.
So you rely on the
OpenSearch.
criteria of relevancy
Well,
of the retriever. So if he decides it's politics versus sports, it will be, let's say, sports instead of politics.
Yeah, if yeah. Then the point is that we can retrieve more documents, maybe, and that will give the LLM the possibility to choose between more documents. I guess there is other way. I imagine that there's a way to do some sort of clustering, like to have to recover just document. If, for example, something else happened the 22 September 22, yeah, whatever it was, 8 September. Yeah. We may imagine that we retrieve some documents that are in the field of I don't know, is it politics? If the Queen die, I guess. Some documents that are in the field of sport, some documents that are in the field of, I don't know, something else. So if I think about it, I don't know if it's the best solution, but yeah, we could use clustering and retrieve just the top document from one of the different fields, for example.
It's a subjective choice, though, right?
The one, yeah, I mean, subjective.
Yeah, the user doesn't say it happened.
Yeah, it can be subjective. I mean, then it's gonna be the LLM. Let's say the LLM retrieved 10 documents. One document talk about the Queen that is dead. One document talk about the I don't know, the Paris Saint-Germain that lost 3-0 against the I don't know who. The LLM is gonna probably pick both. I mean, surely it's gonna pick both because few things happen. Then it's the intelligence of the LLM, the power of the LLM is that it can elaborate the answer and the information. So let's say it's the personal decision of the LLM, which scary as thing, but yeah, like if he has his own mind, let's say.
Thank you.
Welcome.
Thank you. You said that RAG can reduce the hallucination. I have just a question about this. Which metrics that you use to compute the hallucination, and if you can share with us some results of comparing hallucination of RAG and, for example, ChatGPT.
Yeah, the point of how RAG can reduce hallucination is that we rely on sources. If we rely on sources and we instruct the LLM in taking the information only from the sources we give to him, we're gonna surely reduce the hallucination. Because, for example, let's take an example. We saw the King Renoir hallucination. Let's say we are asking the same question to a RAG. What is gonna happen? Essentially, it's gonna search for the King Renoir on the internet, and the first thing is gonna. We can try it even on Bing, for example, on Copilot. It's gonna just retrieve the documents that say that King Renoir just doesn't exist because I mean this is an extremely particular case. Maybe it's not the best case, but let's say, for example, let's say I'm gonna try it. I'm gonna try the same question on Copilot. But yeah, it was going on from the single. Let's see. Then I can be wrong. I saw after the lady on the. Well, like there is gonna search the information, retrieve the most pertinent result, and it's gonna answer in French because. And it's gonna tell us that.
Are you sure?
It's gonna tell us the demo effect. King Renoir is a fictional character from the Song of Roland, which it's quite weird because I searched this on the internet. Oh, yeah. And I found this in what are AI hallucinations. So Renoir, but yeah, Renoir. Okay, maybe it's gonna just I don't know. We're gonna see from where it took his information. I have no idea.
So it's your
But yeah, essentially it depends how we train, not to us we train, but more about what kind of prompt we give to our RAG. So yeah, maybe they don't have the best prompt ever. I showed you that was huge, but maybe yeah, it's faulty. It's insane. But personally, I don't know. I mean, yeah, it's using Wikipedia, but if you search on Wikipedia as well, yeah, we still have hallucination. Maybe with RAG. Depends depends if we say in the prompt use only the document and only the information that you find in the document. Well, it's not gonna give us wrong information.
So what's important is to have the right data, and then the right prompt, and the right model. So actually the prompt is your last garde-fou for the
firewall. Yeah.
Last firewall.
I think we're gonna add this to the next presentation. Why or even RAG can hallucinate.
I'm not sure, but I think it's because of the temperature. So depending on the level of temperature that you specify, it's going to give you more or less hallucinations, basically. So I guess by default, the temperature is high.
Yeah, in this case was in Italian,
creativo might be the equivalent of I, and preciso is the equivalent, I guess, of cold. So that's one. I mean,
that's
that would be the last line of defense, basically. Let's say more or less hallucinations.
Yeah,
more or less.
Indeed, if you see on the code, for my in my case, I picked a 0 0.1 value for the 0.5. No.
One
Yeah,
for
I did.
temperature.
I know temperature one. Yeah. Which I really don't know if it's less or more. I would suppose it's less because I mean I stick to the documents, but I'm not sure. So yeah, you have also to to say to prepare your LLM. There are so many things to do to have everything set correctly. And plus, yes, as we saw, I mean, doing even doing, for example, a demo with the LLM, since it will always generate a new answer, it's extremely complicated. So yeah, imagine with in a real-time use case, in a real use case.
We have to like advance a little bit to give time to Roger
Yeah.
also.
Yeah.
So yeah, if you want to